Okay, we're looking at the first year core textbook and we're on mixed exercise 11, so on vectors, and we're looking at question 9. So this one starts off being about unit vectors. So the unit vector is basically a vector with, so if that's a unit vector, the magnitude of it is 1. Okay, so let's have a look at 9a part 1. So that vector, so 8i, let's just sketch out very roughly. So the 8i is 8 to the right and the 15j is 15 up. Clearly that is not to scale. So that is the vector. Okay, that sloping line with the arrow on. So the current magnitude, so they're calling that vector A. So let's not use A to mean two different things. Okay, so that's vector A. So the magnitude of A I can find just using Pythagoras. So obviously that's going to be a right angle. So the length of that vector is going to be root 8 squared plus 15 squared. So I'm going to be lazy and put that on the calculator. Okay, so that's, sorry, I should have known that. That's a magnitude of 17. So the unit vector, again, this is not drawn to scale, is going to be a vector that's parallel to A, so going that same direction, but just has a magnitude of 1. So if that, so we've just worked out that that vector has a length of 17, so we just want 1/17 of that. We want a length of 1, so our unit vector is just going to be 1/17 of the original vector. Okay, so basically all it is, I think you get a little formula in the book for this. But basically it's work out the length of the vector they've given you, and then so if the vector was too long, I'd want a half of it. If the vector's 17 long, I want 1/17 of it. And you'll find, depending on how they've worded the question, you'll find just to leave the 17th out as a common factor. Obviously I could put 8 over 17i plus 15 over 17j. That'd be another perfectly fine way to write it out. Okay, so let's just quickly run through the rest of part 1 without even sketching them out. Okay, because you don't need to. So the magnitude of B is root 24 squared. I'm pretty sure that's 25. I'm a bit rusty on my Pythagorean triples, so let's just double check. Yeah, so the magnitude of vector B is 25. So the unit vector is 1/25 of vector. Sorry, my writing's getting worse and worse. Okay, so 1/25 of vector B. Okay, what are we doing now? C part 1. So the magnitude of vector C, so the magnitude of this vector here, is the square root. So obviously if I'm squaring, I don't really care that it's -9. So 81 plus 40 squared. Okay, so these are all giving me integers that for the length of the original vector. It's fine if they don't. If that had ended up to say root 41, that's fine. You can have a fraction that says 1 over root 41. This makes it look a little bit more awkward. So what? Hang on, sorry, don't know why I wrote. Just keep writing A everywhere. So that was the unit vector B. This is unit vector C. So it's 1/41th. That's a right mess, isn't it? Right. So it's 1/41th of the original vector C. So minus 9i plus 40j. And then, last but not least, D part 1. So the magnitude of D is root 3 squared plus 2 squared. So I think we're going to end up with a surd for this one, aren't we? So that's going to be root 14. So the unit vector D is going to be 1/14th of vector D. Okay, and let's just double check I haven't done anything daft for part B. Oh, I have. Yeah, no, I can't do 9 add 4. Let's try that again. So that's not 14, that's 13. We'll pretend that didn't happen. Okay, all right, so let's check the others. 1 over 41, 1 over 25, and 1 over 17. Yeah, okay, that's good. Okay, so then the angle. So again, we'll sketch out the first one, but then we'll just quickly do the working for the rest of it. So now we're looking at part 2, and what do we want? We want the angle it makes with I. So again, so let's just sketch out vector A. So vector A is going 8 to the right and 15 up. So again, quick not to scale, or very, very roughly to scale. So there's vector I, and we want the angle with the I vector. Well, so the I vector is basically your in the positive x direction. So that's the angle they want. Okay, so obviously I and J make a right angle with each other. So I've got a right angle triangle, so I'm thinking SOHCAHTOA. I've got opposite and adjacent, so I'm using tan. So tan theta is opposite over adjacent. Not sure what that's supposed to be. Then that might be me trying to underline I. Right. Okay, so theta is going to be arctan 15 over 8. So shift tan 15 over 8. So to 3 significant figures, that is giving me 61.9 degrees. Quickly check that. 61.9, yeah, and so the only other bit of information they're giving is whether it's above or below. So when they say above, they mean like I've sketched there, that's obviously above the I vector. Okay, yeah, so for these actually it might be worth doing a quick sketch, just because it only takes like 5 seconds and it just shows you whether it's above or below. So vector B is going 24 right and 7 down because it's minus 7j. Okay, so still Pythagoras, so there's vector B. So this time, as you already just saw from the solutions, we're going below the I vector. So still right angle triangle, still tan. So this time tan theta. So I can still just do 7 over 24 because when I'm looking at the right angle triangle, that side has got a length of 7. So theta will be arctan 7 over 24, so I'm getting that 16.3 degrees. And as we can see from our diagram that that's below the I vector. Okay, so let's quickly finish these off. So C is going minus 9i, so that's 9 to the left. And sorry, it's a bit of a stupid place to draw it. Let's give myself a bit more space because I need to go up. So minus 9i and then plus 40j. So it's going off in that, oh, sorry, you can't see that, going off in that direction. So again, it's a right angle triangle. That's the angle with the I vector. So tan theta is opposite over adjacent. And again, I'm just looking at the length of it at this point, so I don't really care that it's minus 9. So theta is going to be inverse tan or arctan, as we call it, of 40 over 9. So I'm getting 77.3 degrees. And that is, well, actually, if I think, so the direction it's going, the angle it's making with the I vector is really, let's grab a different colour. So there's the I vector, kind of, I just carry that on. The I vector is going in that direction. So it's really that angle there I want. This is the angle it's making with the negative I vector. Okay, and they might accept either answer, I think, but really that's the angle it's making with the I vector. So I didn't really put that in the calculator, did I? Never mind. All right, so that's 102.7, but I'm going to 3 significant figures, so that's 102 degrees above the I vector. Okay, and then for D, we're going 3 to the right and 2 down, 3i and minus 2j. So that's vector D. So theta there. So again, so this is going to be below below the I vector. So again, I've got a right angle triangle. So tan theta is opposite over adjacent. So theta is 33.7 degrees, and that's below. Oh, sorry, that's below the I vector. Okay, let's just double check. I just want to see what they've put. Yeah, so yeah, they've done the same as we did for that one. It's get my diagram back up again. It's that angle though. It's that angle there. Although hang on, I did something a bit silly with my rounding there. I think I have, haven't I? Yeah, sorry, I don't know what I was thinking there. That's going to be 103, not 102. Thinking their answers, they've gone to 4 significant figures, which we shouldn't really do. You'd get away with it, I think. It's in core maths, and they haven't said. Yeah, so that should be 103 degrees, not 102 degrees.